Okay, so the first thing I'm going to show you is the Platform9 EMP Cost Analyzer. So before I start that, I want to share a little bit about the environment
Yep.
that I'm going to show you, and then I'll show you how we calculate some savings based on what your cluster looks like. So I have in AWS an EKS cluster. Its name is Dev1. Okay, it's got 15 of these EC2 worker nodes, and they're all M5.4 XL nodes. Okay, so there's 15 of those, and they all cost about 78 cents per hour. Okay, so that's the environment that we're starting with here, and then I'm going to go over here and I gotta put my glasses on.
And while he is doing that, just one thing I want to call out, this cost analyzer component he's going to talk about, that is an independent sort of tool utility that we provide separate from EMP. And its goal is to quickly give you visibility in your environment. How much do we think we can save for you? So he's going to start by showing you that, and then we'll get into actual EMPs.
Okay, so on this cluster right here, I'm not running any EMPs. All the instances are EC2 instances, okay? And all I've done is deployed the Platform9 Cost Analyzer. I'll talk to you how we do that here in just a second. Okay, but this has been running for about 2 weeks now. And this first number is you can save about 66% by of your EC2 instance spend. So if you take these guys, 78 cents times these for a full year, you're going to spend about $100,000 for those EC2 instances. Okay.
What about if we're using a Fargate profile in our node pools instead of EC2 instances?
Yeah, so I can talk about that. So think of EMP as an alternative to Fargate, right? So Fargate gives you the serverless benefits, it's managed.
Yep.
We do that same thing for the worker nodes that we manage.
Okay.
But we can't plug into Fargate. So you have to use this as an alternative to the Fargate profile.
Got it. Okay.
Yeah.
Okay. And so we project in a year it'll cost $100,000. And we project that we'll save 66,000. So your new cost for this EKS cluster with EMP is going to be about $34,000. Okay. And so one of the ways we're doing that is we're reducing. So there's these 15 EC2 nodes. We're running them on one bare metal node, right? So that bare metal node costs about $4.60 per hour, and then we're running 15 of these exact same EC2 instances in that bare metal node. Okay.
So how are you comparing this against AWS's own serverless offering, where they just kind of admittedly say they'll abstract all of this away from you and you just...
Are you talking Lambda or Fargate profiles? Lambda.
Yeah.
Well, the thing is, Lambda doesn't integrate with EKS directly, right? Fargate profiles do, and Fargate tries to achieve. So in fact, if you today have EKS cost problem, you go to AWS, they'll recommend Carpenter to you, and they'll recommend Fargate to you, right? But the thing with Fargate, though, Fargate, sometimes this is a matter of opinion, at least in my opinion, Fargate does a great job of automating that worker node management. It's not really focused on helping you save cost. So in fact, sometimes the Fargate costs can actually be higher than just using regular EC2 instances, et cetera. But the Fargate benefit is that you don't have to manage the worker nodes, which we provide. We provide the same benefit.
Plus just certain capabilities overall, like with Fargate profiles, you can't use like Istio or Linkerd as a service mesh. You can use AWS's service mesh, but that's the only one. So there's particular things that you can
their service that's pretty opinionated.
Exactly, yeah.
I see, yeah.
Okay. So this is kind of the, you're looking at Platform9, you want to see how this might impact your environment. You've got a cluster available, and we can run our installer. So to install the cost analyzer, it's a simple Helm chart. When you just Helm install, and we give you all the directions right here. You copy and paste it. It does use a AWS secret key and access key. So, and then let me filter this out. We also have visibility into any other EKS clusters that you're running here, right? So on the Dev1 cluster, that's the one I'm talking about. We have the cost analyzer installed. We have a prod cluster here it's not installed on, and I have a third cluster that I'll talk to you about in a minute where I've actually got an EMP up and running.
So you just sparked a thought. Is this works with Nitro as well? You mentioned key management and secrets.
Say that one more time.
You mentioned secrets, and that just sparked a thought of whether this is working with Nitro instances as well, or is it just base?
I'm not sure if I fully understood, but are you talking about AWS Nitro?
Yeah, service.
The virtualization capability,
Yeah.
right? They do the IO virtualization Nitro card. So the bare metal instances that we deploy, they actually come with those Nitro cards. So we do leverage them.
Cool.
Yeah.
Thank you.
Okay. And then the last thing is we have some charts that we can view over periods of time, right? This is the Dev1 cluster. You see the cost prior to Platform9's EMP and the cost afterwards. Okay. So, this is month to date, $1,923 we've spent on this cluster. And if we've been running it on EMP, it costs us $649. So significant savings there. Okay.
So the goal of this tool is just to give you a projection of how much we think we could save for you. And then you can, as you will see, when you actually switch to EMP and you deploy workloads, the actual savings may be a little less, a little more than this, but this is the projected savings that we think.
And in this example here, was I right in saying that those 15 nodes are suggested to run on one physical server?
That's right. Yeah. And we try to show that to you in the overview. So what we're saying is...
Does that then bring in some availability concerns?
That's right.
Okay.
Yes. Yeah. So in practice, I mean, this is an example with just one cluster, but in practice, we hope that you will have multiple
It's going to bleed out into multiple.
Yeah.
And is there then a way to, do I need to consider, I guess, where my workers are running and distributed across those physical nodes as well?
So you don't need to worry about that, as long as you specify your constraints with us, right? Which is, I want to be across availability zones, for example, for my app, and then I always want 2 bare metal nodes, for example, in every AZ. Then
so that
we will make
defined
sure. Right, exactly. And he'll show you. You can configure all of that, and then we'll make sure that we maintain that. Yeah.
Okay. So what I'm going to show you next is, I'm going to kick off a demo, then I'm going to switch gears to how we install, and I'm going to come back to, because I'm going to generate a lot of load in this cluster. We're going to show you how this thing can scale. Okay, so what I've got is my Dev2 cluster. It's an EKS cluster, except it's running completely on Platform9's EMP. So we have 2 bare metal nodes. Okay, inside, so it's exactly the same as this cluster. It's actually got 13 nodes right now. And we're running M5 8XLs inside of here. So these are just EC2 instance types running on as VMs on this bare metal. Okay, and what I'm going to do is, this is kind of a third node that we'll provision here in a minute. So I'm going to use harness.io. I'm going to use the load hog, and I'm going to kick that off. We're going to watch our CPU utilization on each of these worker nodes inside of that cluster start to skyrocket. Then we're going to see the underlying metal skyrocket. Then we're going to see it automatic to keep application performance and availability consistent. You're going to see us spin up a third metal node. Then our load balancer is going to rebalancer. It's going to rebalance these nodes across all 3 of those nodes. When the load goes back down, of course, then it'll scale back after some time.
I have a question.
So I'm going to kick that up.
Yep.
That all sounds fine, but are you, and maybe this was answered and I missed it, but are you collecting information to look at trends and forecasts over time? Because right now, when I plug this in, you're going to take all this action, but it may or may not be necessary. You have no idea.
That's right.
When you start. Okay.
That's right. So there's different things that we do, because what we want to avoid is the constant flip-flop, like we're just spawning a new bare metal, we're taking it down. That's kind of what you're talking about. And so the rebalancer, it kicks in the moment you create a first instance of EMP and is constantly collecting metrics about your applications, about, it is also aware of the request limit values, et cetera, by the way, and it's collecting metrics at the VM level, right? The other thing that we're currently building, that's not in yet, is we also want you to make us aware of some known burst patterns that are going to happen in your application's usage. And this is in response to requests that we've gotten from our design partners we're working with, which is, I know, let's say every week on Saturdays at 9 p.m., I get bursty traffic, and I want you to deploy some pre-warmed capacity so that you're able to handle that massive burst. And we're just adding the ability to do that as well.
And are you looking to do predictive analytics over time?
Absolutely. Yes, exactly. That's our goal. But that will require us to also collect some data as the product gets deployed more and becomes more mature. But absolutely, yeah.
Sorry, you mentioned I think you said rebalancer before. Is
Yeah.
that something directly out of EMP,
Yes.
or is that okay?
Yeah, so it's a component that EMP installs. It's a component that runs kind of behind the scenes,
Okay.
right? And it is always, and that's the component that's collecting the metrics. It's always watching, and its job is to distribute the workloads evenly across bare metal nodes.
Okay, got it. So then, if that's the thing that's distributing the workloads evenly, is it fair to say that the assumption is to disable cluster autoscaler?
So what we do is, see, this rebalancer kind of operates behind the scenes.
Yeah.
You don't disable cluster autoscaler because that is what is doing the provisioning of the new nodes, right? It will still scale out, and
Yeah.
we will continue to leverage the cluster autoscaler for that part.
Got it.
Yeah.
So it uses both. We have the
Yeah.
rebalancer and a cluster autoscaler, so the cluster can dynamically scale as well.
Got it. Makes sense. Okay.
Yeah. All right, I'm going to get this kicked off real quick. So I'm using the CPU hog on my chaos experiments here on Harness. Right? I've got my nodes defined here for all of my worker nodes in that dev2 cluster. Okay, and so I'm just going to save this, and then I'm going to save, and I'm going to kick it off. Okay, so this will run for 15 minutes or so as it generates very high CPU load across all that. And then you're going to see dynamically this third node right here spawn up in just a minute. Okay, so while that's happening, and I just want to show you one thing before I do that. If I come to my Elastic Machine Pool and look at my EMP here, I have this dev2 EMP, right? If I look at him, first up here, you can see I've got 2 bare metal nodes deployed. It's really small font, but there are 2 right now. There will be 3 in a minute. And then you can see my CPU utilization here is at 2%. Now this is the CPU utilization on that chart of these bare metal nodes. Okay.
Yeah.
In addition, I can then look at my EVM pools, right? And here, I can see my CPU utilization across all those nodes that are making up the EVMs. That's these guys right here. These guys right here. Okay. So we'll come back in a few minutes and we'll see the load spike. I'm maxing out CPU on all of those. Okay. All right. The next thing that I kind of want to do, let me show you what I'm going to do first. All right. So this is my last EKS cluster I have. AWS EKS, and this is my prod cluster. Okay. Same exact model as all the rest of these. It's got 15 M5 4 extra large. Okay. What I'm going to do, I'm going to walk through our UI, and I'm going to walk you through how to create this on this cluster. Okay. So I'm going to what's going to happen is it's going to create EMP. It's going to create these 2 nodes, right? And then this cluster will actually scale from 15 EC2 nodes to 30 nodes. And then at the end, we probably won't have time for that, but we'll end up deleting those, and you'll be running fully in that kind of picture there.
And Peter, you spawned the workload, right, on this already?
Yes.
So the migration strategy is just expanding the cluster across the worker nodes and then pulling the old ones out.
That's right. Yeah. So when you scale out and when all of the bare metal nodes are filled, then we will, expand, add a third node, but we'll also take it out. So the nice thing with bare metal, unlike say something like VMware where you're limited in capacity, is with AWS we can even expand the bare metal. Maybe I didn't get your question.
No, sorry, I was talking about the EK. If you're in a EKS today, moving into EMP.
Ah, okay,
So-
got it.
Yeah, is that just a matter of provisioning EMP, that which will expand the existing cluster? Workloads will migrate across and will decommission the original
Yes.
EKS.
So, and I've got an app that's actually running
Yep.
in this, right? And I can show you that here in a minute. But so you put a toleration on these, and you can say, hey, I only want certain workloads to run over here.
Yeah.
Okay, or I want to delete all these, right? And then the Kubernetes scheduler will reschedule the workloads to come over
Yeah.
here.
That's your non-disruptive approach.
That's right.
No re-architecture. Yeah.
Exactly.
And what the rebalancer does, just so that it's clear, is it takes one of these VMs, right? And right now we're running 6 and 7 on here, and it'll be 5, 5, and 5 or something like that, right?
Yeah.
So it'll rebalance this. This is a VM. It'll put it over here, or it'll put it over here, and so that's moving, and that's actually the worker node for the EKS cluster that's getting moved over into a different physical server.
And is it this is probably too detailed, but is it the component that you refer to as the rebalancer that's also doing the utilization monitoring of the workloads and such? Is that all?
That's right. Yeah. So it has its kind of sub parts that are collecting
Yeah.
all that data, and then it creates the snapshot, and that's what it makes its decisions based off of. Yeah.
Cool.
Okay. So let me walk through how to create an EMP real quick. So I'll go to the create EMP, and it comes up with this wizard. Okay. It's going to ask you for the EMP name. Put EMP-prod in here. I have a cloud provider. That's my AWS credentials. I'll select that. I'll go into US East 1. Okay. VPC peering is a new functionality, and it's beta right now, so I'm going to kind of skip that. But then I'm going to select the cluster that I want to deploy this in. Okay, so I'm going to use the prod cluster. Okay, we can have multiple EKS clusters running on an EMP pool, so you can use bare metal to run 2 different set of worker nodes for different clusters if you want to.
I got to ask the question. I'm assuming yes, but see version 1.25. Has EMP been tested 1.26, 27, 28?
So
Yes.
Okay.
Yeah. Yeah. Yep. That's right.
yeah, this is just that's the version of the EKS cluster that I deployed.
Yeah. I just it's
Yes.
just pretty old. So
No, we're not on 125. No,
Yeah,
we're
okay.
supporting. We try. Our goal is to follow the AWS compatibility,
Yeah,
at
yeah.
least a subset of it. They're pretty aggressive actually in terms of how many they support. But yeah.
Okay, so the next thing is traffic in the EKS control plane needs to be allowed to talk to the bare metal nodes. Actually, the bare metal nodes and the Elastic virtual machines running inside of those. So we can modify those security groups for you, and I think everybody's going to do that, or you can make your own changes. Okay, so in this cluster, I'm going to select my. Let me scroll down here a little bit.
If you choose to make your own changes, do you have like a list of the ports that are needed somewhere in the docs, I'm assuming?
Yeah. So there's a doc link. I think it points over there. Refer to this article for how to perform it yourself. So we put that in there.
Yep. So I just selected that
Do you
EKS.
provide any type of automation to make that yourself, like to review the changes that you would do on our behalf? So if I said, yes, I want you to do it, but I want to see it, there's the article, or do you have a template that I can view, like CloudFormation, Terraform, or anything that will do it?
Yeah, I think that's a good. We don't for this part. We give you a template to configure your IAM user today, a CloudFormation template. But I think that's a good feedback on this part, just to give you full visibility, I guess. Yeah.
Okay. All right. And then the bare metal pool name, PM pool prod. And what kind of metal instances do I want to use underneath this? So I can select, if I know it's a compute intensive, I can select a compute a C metal node. If I know it's memory, I can pick one of those.
Are there any recommendations that you provide based off of? Right now, you don't have visibility into it except for my AWS account on how well I'm utilizing my resources. But now I'm looking at this is that I'm going to go select the best one because I don't want any issues.
So what we typically say is, let's say you're currently, look at the profile of your instances. If you're consuming from the M5 family, like you have M5, 4x large, 3x large, then pick the M5 metal. Or if you are consuming from T2 family, which not a lot of people do for prod today, still pick the M5 metal. It's a general purpose family, right? But if you have specific use cases, so you're using today compute optimized or network optimized, then for every family, AWS makes corresponding metal instances available. And so we give you the flexibility to deploy that.
So let's say I had 3 node pools. I had one that was CPU centric, I had one that was CPU centric. I had one that was memory centric for memory centric apps, and GPU centric for GPU centric apps.
Yep.
If I had those 3 node pools for different use cases, that means I need 3 EMP nodes.
Yeah, so I'll qualify that by saying there are cases where you absolutely need those, like GPU and
Yeah.
CPU, just hardware is different.
Yeah.
But many times, people tend to use different families for different reasons. And they may not always translate to us having to create those node pools. Like
Okay.
many times we say, I see that you're using some CXs and some MXs, but you can put all of them on the M family.
Got it.
So
Okay.
yeah,
I gotta ask the question.
Yeah.
then. If let's say we took that scenario, right? We had those 3 node pools for particular application stacks, and then maybe we would need 3 bare metal instances for EMP.
yes.
It's going to be costly.
Yes, so there is a minimum size for EMP. There are environments that EMP will not be a fit for,
Got
right?
it. Okay.
And the more you start slicing and dicing based on
Yeah.
such hardware needs, the the difficult it gets.
Right.
Yes. So
Yeah, I guess I would be fearful of like, oh, this is going to cost me a lot of money.
that's right.
Thanks.
So what we do is we try to give you. That's why we build the cost analyzer, and we also try to give you the visibility in the dashboard because we will not make any money if you don't save any for you, and we want to tell that upfront
Right.
to you.
Right. Yeah.
Because the worst thing that would happen is that we cost you more at what you're running today, right?
That was
Yeah.
what I didn't want to say.
That's right.
That was, yeah.
No, that's right. That's absolutely right. So there are small environments that we would just not be a fit for
Makes sense.
for a lot of those reasons today.
Yeah. Sounds-
Okay, so running back through this install, I've selected the M5 metal type. Okay, it's got 96 vCPUs, 384 gig of RAM. And then I'm selecting the availability zones that I want. I only have one VPC, so it's selecting that. Okay, and then I'm going to say my public subnet here is this one, and I'm going to select that. So I have to define the subnets that we're going to use for communication back and forth to the metal nodes as well as the EVMs running inside of this. Okay, and then we select the minimum number of machines and the maximum number of machines. So I could say from the bare metal perspective, I could have just one, or I could say I want 25. Okay, and we won't deploy all 25 right off the bat, but we would scale to that as the workloads grow. So right now I'll just do 1 and 4 or something like that.
And that's that configurability. I think he was asking for earlier, the availability zone, the min max, all of that you were able to configure.
And it says optional, I'm assuming, because it's like if you don't set anything, just let Platform9 take
That's
care
right.
of it.
That's right. Yeah. The minimum we can't really predict on your behalf. We will start with 1, but
Yeah.
then everything else we kind of
Got
take care of.
Okay, so as part of the EMP creation, we're now creating an EVM pool. Okay, so I'm going to just set my M5 8 extra large, it's the EVM type, similar to what I've got running up in that one already. So the end state of this one will look like that one when we're done. Okay, have my SSH key, root disk size, we just take the defaults for most of this stuff. And then the min number of EVMs do you want to run, right? Do you want a minimum EKS cluster size with 4 nodes? Or do you want a minimum EVM size of 20? It doesn't really matter. We just specify the minimum, and it can scale from there. So I'll just do 4. And then sort of the last step is dash prod. We have to name this. We're going to associate it to the prod cluster. We're going to click next. And then it's just a review of all the kind of options that we selected, and I'll create this thing. Now this is going to take some time. It's going to take 15, 20 minutes or so to create. We might not have time to come back to that, but we can talk about it afterwards too. Okay. Now, the next thing I sort of wanted to do was I wanted to go back to that dev2 EMP, because that's where the node's starting to scale and the CPU utilization is going up. So I'm going to go over here. Taking some time to load.
There we go.
So now we can see the CPU utilization on these 2 bare metal nodes is 84%. Okay, so that's cool. So what that's doing now is it's going, okay, we need to go into a scaling event to scale the metal, and then we're going to then scale and rebalance the EVMs across all 3 of those machines to guarantee your performance level. Okay, so if I look at the pool here, I'm guessing anytime in the next 5-7 minutes we'll see this go from 2 right there to 3. Uh,
You can go to EVM pool and show the utilization
will.
there too.
I will. Yeah, I'll do it now. That's fine. All right, so we have this EVM pool. It's called dev2-9. It's running. If I look at the nodes running in here, you can see each one of these is now starting to scale to about 30%, increasing utilization on those. So the CPU hog is really starting to crush this, and that means the CPU is going up on those bare metal nodes to kick off all these scaling events. Okay. So, okay. Go back here. We can't, so you can see this one's got one EVM pool here associated with it. I can have 2, 3, 4 different EVM pools with different EC2 instance types or VMs that can run inside of that, right? So these are, the ones inside of here are all M5 to 8 extra large. And then let me go back here. Okay, so we can have more of those. I can see the imported cluster. I just know that this is the one I've already bootstrapped. It's the dev2 cluster. When that deployment finishes, we'll actually see the prod cluster listed here as well. Okay, if we're using VPC peering, then I go there. And then the metrics. This is kind of interesting because now you can start seeing CPU utilization to scale up, right? Our memory is going up slightly. And so we just have some metrics of what's happening inside that cluster. And now it's just a matter of waiting to see when this cluster, when this bare metal pool should scale. You want to go through the dashboard?
Yeah, and also one cool thing we could show. Yeah, so the dashboard is one, and we could also show the AWS console. So
sure. You want to?
Yeah. So the dashboard basically, we looked at the cost analyzer that kind of gives you a projection of how much the cost savings EMP could give you. The dashboard now is telling you actuals, right, along with some projections. But this is based off of the cluster that is now running on it and the cluster that we just triggered load on. And right now, we project that we can probably save about 44% of the cost of your, of your base EKS cluster. And so this number will keep on getting adjusted as we better understand your workload spikes and what your utilization, et cetera, is, and therefore where we think we could take you with EMP.
The EVMs will scale, the metal pools will scale. Once load goes down, it'll all scale back down, right? And it won't be just a flat line, so you'll be more up and down on the savings.
So in your presentation,
yeah,
Lloyd?
Yeah.
Have you got the data of how much you've saved at a total aggregate level across all those nodes? So, like reports back from all of the systems that you deploy for all of your clients that goes, I know we got 15, well, I can't remember what the number of nodes was.
Oh, the 15,000 nodes that we have.
15,000 nodes, and we've saved on average X%. Do you know that?
So that data is for our private cloud product, the 15,000 node count we talked about. This is a brand new product, so we don't have that kind of node management yet under it. But that would be, we'd love to come back next year and share that stat with you. But
so you're not using this for the private cloud product?
What's that?
Are you using this for the private cloud?
No, this is just focused on public clouds.
Only public cloud offerings.
That's right.
Okay.
Yep.
Okay.
Okay, to that end then,
yeah,
that's, I think that may be a different question. I was going to talk about go-to-market strategy, so hold that for the other.
Yeah, okay.
Yeah.
Ask your question, do it.
Yeah, ask away.
It's a different audience than you're going to be talking to.
Okay.
Right.
Yes. The target user still remains the DevOps platform ops profile.
Yeah, it is.
But instead of managing private clouds, well, we see that there's a lot of blend though. A lot of people who managed VMware before are now managing AWS environments and et cetera. So it's a similar profile. But you're right in that there is a very sort of specific cost focus here, where the focus is different.
Yeah,
with that
a very different value proposition.
That's right. Exactly. So yeah, so what we like to show here is these are the EVMs, and they actually show up in your AWS console. So they look and feel exactly like your EC2, virtual machine nodes. There's absolutely no difference. The only way to tell these apart is if you actually look at the labels of some of these nodes, and you will see that they're tagged with EMP. So
yeah, this node name here, you can tell it's a little bit different. If I come back to one of my previous clusters here, let me just go back And I go to the prod cluster and I look at the compute nodes there. They're all in the EC2 kind of format of how they label their nodes. So you can tell the difference that those are EVMs and these are EC2 instances.
Right.
Okay, let's go back and see if we've scaled yet. And it has not scaled yet. So it take there's cooldown times and it has to stay up for a moving average of 5 minutes, and then it says, okay, then let's build this thing out. That takes a couple of minutes to build the EC2 bare metal, and then we deploy our software. So sometimes it can take a little bit of time to scale that out.
And one of the things we can do, Peter, is demonstrate creation of new EVM pool.
Sure. So I'll come over to EVM pools, and I can add, so I was talking about this earlier, we can have as many EVM pools as we want. By adding a second one, it's the same wizard that we went through when we created the EVM pool. I have an M5 8 extra large. Maybe I want to do an M5
4x, maybe.
4x large, sure. Okay, we'll put my SSH key on there. Disk size, that the minimum number of EVMs for this pool, right? This is something that's kind of cool. This is where we can control the amount of overcommitment, right? So on these AWS Metal nodes, we can oversubscribe these nodes, similar to what VMware does and OpenStack does. And we can say, hey, we want to do a 16x multiplier on CPU and 1.5x multiplier on the memory.
I have a question here. Do you have some specific guidance how much you should, how much overcommitment, over provisioning you should do to not excess some amount?
Yeah, no, absolutely. So what we do that is, once we get sort of a profile of your environment, right? Let's say that we measure that today your average utilization, and let's say memory is the constrained resource, and it's at 17%. Then we say to you that by using a 1:1.5 ratio, which we think is not too aggressive, we can still pull it up, to an amount where we are not pushing the bare metal pool. So
and this comes as an automatic feedback from the system. Like I get the information, I don't know, some notification, hey, Maciek, you should do this 2 to 1, right? Or I need to go to every time in this properties and change it by myself?
So today you do have to change it. Okay. I think it would be awesome, and I agree that the system kind of either just changes it on your behalf,
but just inform,
Or inform, yes. I think that would be a nice thing to do.
Okay. So this is, I just went through the remainder of the wizard. I set it to 2.5 overcommitment on memory, and I'll click add. Okay, so now this is adding that EVM pool to this EMP, and it'll add one more node because I set the minimum size to 1. So that cluster is actually going to go from 13 nodes to 14. And if we don't have the capacity on these 2 nodes, that's also a scaling event where I would add another bare metal node.
So what you're doing here, is this a service you provide for your customer? Or do you expect them to do this?
No, so this is, all of everything that Peter is doing, we expect the customers to use the product and do it themselves.
Okay. So if they knew enough to do this, wouldn't they also know enough to manage their Kubernetes environment a little better?
A little better, yes.
Okay.
But see, some of what we're doing at the virtualization, etc. layer, it's just very difficult to do it in a DIY manner, right? So I think that's the part that is kind of difficult to do. But yes, if they are that advanced user, they could also try to tweak the requests and limit values, etc.
Do you offer recommendations to them and say, by the way, here's a few things you could do in Kubernetes to streamline things?
That's right. So, and that's the feedback we've received. So you can see some of the metric charts Peter was showing. We already show you some of the request and limit averages, etc. But people want to see that in a more granular format, and we're going to add that in the product as recommendations in terms of what you should do.
Yep. So we're just in that waiting loop now for it to come back and realize that I've already scaled.
Yep.
I may have missed it. When did this go GA?
So this is right now in limited availability. So it's for GA. So
what's the target? Are you okay us talking? I'm assuming you're okay us talking about it
Absolutely, yes.
There's a
yeah.
blog post on it, so I'm assuming.
Yes, yeah, this is already out.
It's public, and I've
That's right.
quoted it and put it in the article. So.
Yeah, that's
Absolutely, yes. This is public.
the GA date.
Right now, we're hoping somewhere around between March end to mid-April or so is when we're able to take this GA.
KubeCon would be a great location for you if you're not.
That is true. That is true. Yes. Yep.
Just
Yep.
thinking out loud, if
That's
you're looking
true.
for a launch related,
Yeah.
If it's ready.
I
if
agree.
it's ready,
That's true.
that's your perfect place.
That would be a fantastic place to do.
All
to
that
do
crowd are
launch.
going to be there.
That's right. That's true.
All right, Maria, we have about 6 minutes. Do you want to do the wrap-up slides and then?
Yeah, I mean, I think in terms of wrap-up, it was just more of a conversation, right? I mean, the key value proposition that we started this with is to help save cost in a very specific way, and doing that in a way that we think it's just not done by the tooling that's available today, right? And so while this product today is focused on EKS and AWS, as you can see, the technology is not limited to that. Our goal is to expand beyond to other Kubernetes offerings, potentially to EC2 as well. But yeah, we're very excited. We're hoping that through this, we can help tackle probably one of the most pestering challenges when running Kubernetes in the cloud today. So
Keep hoping in the last 2 minutes here that this is going to scale on us.
It's the
We believe.
live
It's
demo.
the internet.
it's the infamous live demo.
Yep.
I mean, it's going to scale. It's just those.
Yeah.
I'm just thinking automation, kind of Ansible connectivity, stuff like that. Maybe not a badly formed thought process in my mind without a specific question, but you kind of seeing automation and specifically Ansible connectivity with this? I'm kind of seeing an automation loop in my mind, but
In terms of how end user could automate things.
yeah.
Something like that.
Yeah.
Yeah. So what we typically see is Terraform is the most common thing in AWS that people use for automation. What we don't have it yet, but what we want to provide is a Terraform provider.
Asked this question about
Yeah.
form earlier.
Yeah, exactly. So we want to be able to plug into your current automation that spawns your EKS clusters and give you a provider so that for your EKS clusters new, your worker nodes will always be EVM worker nodes. That's kind of our goal.
And everything behind this has an API. So everything our UI
So
talks to an API.
You just
So
connect in the.
if you wanted to go to a RESTful API and do everything I did in the UI today through an Ansible automation, you could do that.
That's what was sparking the.
Yeah.
That's right.
You tapping the keyboard's great in
Yeah.
one cluster.
That's right.
I'm thinking big cluster scale. How
Yeah.
do I automate that?
100%. Yep. Yeah, that's the end goal, definitely.
I'm just thinking the enterprise customers are going to be using Ansible.
Yes.
Going to be thinking that way.
That's true. Yeah. I mean, I think we see.
In a small scale,
Yes.
people are going to be hands-on tinkering with it.
That's
I'm
right.
thinking like Citibank
That's right.
type scale. They're going to be thinking,
Yeah.
they're going to have an automation strategy. It's going to probably be Ansible.
Yeah, they're definitely not going to go through clicky UI.
Yeah.
So we're going to.
They'll be wanting to automate that.
Yes.
But that's just an API connection by the sound of it.
That's right. Yeah. So we already have
Good.
APIs. These are all Kubernetes APIs, and we plan on building some of these providers.
From a go-to-market point of view,
Yeah.
bouncing topic completely, you're going to be in the marketplace for AWS.
We're already in the AWS marketplace. The team has been working on that. I think we're already in there. I think we want to also try to be in the add-on, EKS as an add-on marketplace. Ideally, we want to be there as well.
And is that
Right.
plan for launch to be in the marketplace by then? Ideally, fingers crossed.
What's that?
Is it the plan to be in the marketplace by the time the service goes? to you?
That would be the goal, definitely.
Excellent.
Definitely in the add-on marketplace. And then,
Thank you.
yeah,